Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 3rd, 2025, just yesterday. This paper introduces a new post-training methodology that allows open-source web agents to match the performance of powerful proprietary systems on complex reasoning tasks. The paper is titled WebSailor: Navigating Superhuman Reasoning for Web Agent, and as we'll see, their approach effectively closes a major capability gap in open-source AI. The authors achieve this by generating novel, high-uncertainty training data and using a special two-stage training pipeline. Also, the authors shared their work on GitHub. The repository is a hub for their broader web agent project, which includes WebSailor, WebDancer, and WebWalker. In there, you'll find the code for their training pipeline and some really impressive video demos of the agent tackling those super complex tasks. Alright, so let's dive into the results. These first two charts show the performance on the BrowseComp benchmarks, one for English and one for Chinese. These are incredibly difficult tests that require complex, multi-step reasoning to find information online. And the results are pretty striking. The WebSailor models, shown in purple, significantly outperform all other open-source agents. The 72 billion parameter version even surpasses proprietary systems like GPT-4o and Dubao Search. This really drives home the effectiveness of their training method, which uses a special two-stage pipeline. So, to understand why WebSailor is so effective, this next figure breaks down the different types of problems these agents face. It categorizes information seeking into 3 levels. Level 1 is simple, like a direct search. Level 2 is a bit harder, what they call multi-hop questions, which require connecting a few dots in a structured way. But the real challenge, and where this new method excels, is level 3. Here, the information is intentionally obfuscated, meaning key details are made vague, forcing the agent to reason deeply and synthesize information, not just follow a path. Building on that idea of level 3 problems, this next image shows us exactly what those intentionally difficult questions look like. These are examples from the special training data they generated, called SailorFog-QA. You can see how vague they are. The first one mentions a late antique writer who died around the mid-5th century. This forces the agent to connect multiple fuzzy clues, which is the core of their two-stage training pipeline. That pipeline begins with an initial phase called rejection sampling fine-tuning, which is a clever way to start learning by only showing the model high-quality, successful, and complex examples of problem solving. So that initial training phase is followed by reinforcement learning, a method where the model learns by trial and error, getting rewards for good actions. And this table really shows the payoff. We see the WebSailor models at the bottom, all using a React paradigm, which means they reason, act, and observe in a cycle. On the tough BrowseComp and benchmark, the WebSailor 72B model hits an accuracy of 12%. This results as a massive jump over other open-source agents, and it starts to close the gap with proprietary systems. And this chart really quantifies the benefit of that two-stage training pipeline. It compares the accuracy after just the initial rejection sampling fine-tuning, shown in light purple, to the final accuracy after the second reinforcement learning phase, in dark purple. Across every single benchmark, the reinforcement learning stage provides a clear and consistent boost. This holds true for the tough BrowseComp tests and other benchmarks, like GIIAI and XBench. The numbers are evaluated using pass at 1 and pass at 3, which just means getting the answer right on the first or within 3 tries. So to wrap things up, the WebSailor approach really shows that the path to smarter open-source agents isn't just about bigger models. It's about training them on the right kind of problems, specifically these complex, high-uncertainty tasks. By combining that initial rejection sampling fine-tuning with a more efficient reinforcement learning method called duplicating sampling policy optimization, or DUPO, they've managed to close a significant performance gap. It's a powerful demonstration of how targeted training can unlock superhuman reasoning. That's all for this edition of the AI Research Roundup. Thanks for listening.